All right, take it away, Peter.
Okay, well, yes. Let's talk about managing databases at scale. First, I want to highlight what exactly scale is. As I talk to different people, they really look about that from a little bit different standpoint. For some people, scale means large number of databases and database deployments, and that is important scale. In many enterprises, you find hundreds or even like thousands of small to medium size databases, which is their large scale. You can also look at the scale in terms of a number of development projects, teams, people, and of course, most kind of technical, most of us geek would be thinking about is large database instances or database instances which are serving large traffic. Now, at scale, we have whole bunch of problems. Like for example, if not technology, even if you'd imagine technology is perfect, scaling people are hard. Well, people are in generally complicated. We also have downtime, performance problems, security incidents. All of those get more expensive if your environment is large. And also what that means, what efficiency makes a lot more. Right, like if you're running single database instance, maybe spending time to optimize it to squeeze a additional 10% doesn't make sense. But at Facebook scale, 10% is quite a lot of change, and that's why we worth investing in optimization a lot. Another thing which I think is interesting at the scale is, are you choosing the database or databases? In our experience, we see what many people are choosing to use multiple databases, which improves their efficiency in terms of building better apps faster, because developers can use technology which is better suited for building what they're about to build. But it also can increase complexity, especially if it's run unchecked and you end up using tens of different database technologies. Many of them may be very similar to each other, right? And with that, our best practice would be to use controlled number of databases where you can use sort of a best of breed databases for different tasks, but really control the sprawl. We also believe that at scale, it is a fantastic practice to embrace open source, because software lock-in is much more painful at scale, both in terms of additional cost it tends to bring, as well as in terms of if you want to avoid that software vendor lock-in, to really decouple that at large scale is complicated. At the same time, when you're looking at scale, you need to be thinking about the unification, because if you have all your environments are very different, that will be very hard to manage, right? If you have unification, you will reduce your staff learning costs, right? As you onboarding the staff, operational cost, also reduce people mistakes, which can be extremely costly in scale, both in terms of downtime, security incidents, and so on. You name it. The automation is another thing which we see is being very important at the large scale, and in generally high scale requires high level of automation. What you would see for folks which have DBAs, for example, if you are a relatively small organization, right, maybe have 10 database instances and one DBA, and if you then look at how many DBAs some company has which runs 10,000 of database instances, we're not going to have thousands or times more DBAs. It doesn't make sense, right? In those cases, you would expect what a single person will be responsible for much, much larger number of instances, environments, and so on and so forth. And that requires high level of automation to reduce toil. We are also looking at things like actionable alerting, help to really understand the root cause of the issues, such as automatic correlation, and in the best cases, the self-healing. So systems can recover automatically from at least some part of failures. That is never complete, but at least some basic things like server goes down, or IO disk volume dies. Right, system should be able to handle that automatically. From Percona standpoint, we've been working in this space by building a number of software solutions. Our Percona monitoring management helps with monitoring, not quite yet with management, but we're getting there. And our operators on Kubernetes can really help with a lot of automation work and reducing oil, which I mentioned. The next thing which I would encourage you to consider is to focus not on production alone. In many cases, as we spoke to our customers, we are very much focused about this, how to run databases well in production. And I think even database, similar to their bug fixing, it is similar to bugs, which this graph above corresponds to. It's much easier to prevent the database issues, security, scaling, performance, and so on and so forth with a proper design than trying to resolve that in production after everything was already shipped and written, and so on and so forth. Teamwork is also absolutely essential in this regard. In many organizations, we see there is some sort of conflict, and in a bad way, between operational team and development team, right? Or even kind of developers and DBAs, right? We can say, well, you know what, we now shipped our problem, right? And now it is the database is your concern. You have to figure out how to make it run, make it scale. But guess what? If a system was not designed appropriately, if you have a horrendous schema, very bad bad queries, and so on and so forth, there is no database or no DBA which will be able just to magically fix that for you, right? Instead of throwing that toxic database waste around over the fence, you really need to work together as a team on the problem. The next advice I would have for developers: don't be like those developers which we talk on the picture about. Make sure you understand the database basics, because really, if you want to build a great database power application and at scale, you can't really do it well when you have no idea how database work. You may be able to write some code, ship some code, and then rely on somebody to mop in all those things for you, but that is super inefficient. What things should you learn? Well, at very least those things, right? You should understand the schema design, the data consistency models, especially in the modern world where a lot of cloud databases may have a different and sometimes exotic data consistency models. You want to know that. Really understand the power of database query language, because that often can increase both productivity of developer and performance by many times. You want to figure out indexes, and at least at a high level, understand how database execute queries. Also, if you look at the database standpoint, the queries is very important part, right? Well, frankly, that is essentially the only way how the application interacts with a database, right? If a database stores application queries very well, then developers are happy. If not, they are not. But guess what? If you have a bad queries, then no database will be able to serve them well. And you really want to ensure you squash them or eliminate them in any other way you are capable of doing that. Some tools which exist in the database for that would be something like explain. Right here is example of visual explain in MySQL from MySQL Workbench, which can be fantastic way to understand how query is executed. And here's example from Postgres with tool called piv, which you can visualize PostgreSQL plans with. Learn those tools or large number of other tools which exist for similar purpose, but make sure you can understand what is the bad queries and good queries in your environment. From Percona side, we've built PMM, which is very helpful in all that process to understand which queries are causing the load on the database. Also, you can understand why those queries are causing the load, like to understand how much of that load comes from a lock-in or disk IO or just executing the query itself. And then potentially you can figure out what to do about them. We bring in the most important data about queries such as tables, they touch, the explain plan, additional example of a query, right, which is running, which should give developer or DBA all the information one need to fix that query on the single page. The next high-level best practice is you do not want to run with defaults. This example I taken from recent benchmarks done by our friends at EDB comparing PostgreSQL 13 tuned versus running that with defaults. And you can see what at scale the performance difference is tremendous, right? And so many people are running MySQL and Postgres with default settings. MongoDB behaves better, actually, at least by default. It scales its configuration to the server scale. But even with MongoDB, if you really want to get a best configuration, you may want to tune that for your workload. The next thing you need to mind is your approach to scaling. Vertical scaling and horizontal scaling, both of them make sense for different for a different application, and I think that's very good, important to make the right choices, because if you don't, you may either run into a wall with scaling when you rely on vertical scaling, but actually your application is too large for that, or to have more complexity, which often comes with horizontal scaling. Speaking about horizontal scaling, that's typically done through sharding in all the technologies we talk about. And situation in this case is interesting. Therefore, MySQL and Postgres, there are some third-party solutions which exist and kind of get a good traction on the market, such as Citus for PostgreSQL or Vitess for MySQL, right? Folks from Vitess spoke earlier today. For MongoDB, sharding is built in and frankly, much easier. That was one of the reasons why many companies have been choosing MongoDB to begin with. The next thing you may want to understand at scale is memory and how to use memory properly, because memory is much faster than even the fastest storage available. And having a right memory fit where you have your working sets fitting in memory can be the difference between the database which barely moves and database which is really flies working very well for you. Again, that becomes more important at scaling, where you don't, where any bad choice becomes increasingly more expensive. Now, memory alone is not going to solve all your problem. Some I/O, especially writes, are unavoidable. They have to hit the storage, and in this case, using the proper storage is important. One thing what we see a lot at scale, especially, is there latency outliers, right? When you would have, sometimes 1 in a million of IOPS, you have a stall for 1 second. Well, for many applications, that may not be a problem, but for a database, if that's happened to be your transaction log, right, you will have all your database stall for a second, and that can really have a lot of cascading effect out there, right? So you really want to make sure you have a storage which is robust when it comes to storage in terms of an outlier. The next thing, which we see a lot, people run into a problem with, is understanding speed of light limitations. While I think there are some teams working on it, I am not aware of anybody beating speed of light yet. And so if you really want the synchronous replication between US and China, for example, it is not going to be achieved with sub-millisecond latency, just because of a speed of light limitation, right? And that often conflicts with those kind of nirvana ideas about what developers may want to see, right? Which can say, hey, wouldn't it be wonderful if I have this cluster where I can write to it from anywhere and it's geographically distributed across the whole planet, right? Which will be very reliable, and also will mean I can serve my reads locally. Finally, I think one of the great practices at scale is do not fail alone. We see so many problems at scale which are entirely preventable with working with experts. And wherever you choose to build that experience in-house or work with some the external partners, well, do that, because databases are complicated, and it is not a great practice to just try to win them, especially at scale. That's all I have.